So welcome student. This is the another class of electrochemistry. So in this video, in this class we will read what is Kohlrausch law. So in the previous class we have read Debye-Hückel-Onsager equation, and from that equation, what was the equation? Lambda m equals to lambda m naught minus a into root over of c. So from that equation, it was very difficult to calculate the limiting molar conductivity of weak electrolyte. That means for a weak electrolyte, lambda m naught value cannot be calculated easily. So that's why lambda m naught value for weak electrolyte, how it can be calculated? It can be calculated by Kohlrausch law. Okay, so what is Kohlrausch law? So Kohlrausch law, first you see one example, then we can predict what is the law. Suppose lambda m naught of any electrolyte, suppose lambda m naught of NaCl equals to, okay, lambda m naught of Na plus lambda m naught of Cl minus. Okay, similarly, suppose lambda m naught of magnesium chloride MgCl2 equals to lambda m naught of Mg2 plus lambda m naught of Cl minus. How many chloride? 2, so into 2. So this is called your limiting molar conductivity of electrolyte equals to sum of the conductivity of cation plus sum of the conductivity of anion. This is called Kohlrausch law actually. Clear? So how can you define Kohlrausch law? So theoretically, Kohlrausch law states that the limiting molar conductivity of any electrolyte at infinite dilution equals to sum of conductivity of cation and anion. Sum of conductivity of cation and anion. So this is called Kohlrausch law. Clear? Similarly, sir, for weak electrolyte, how can we write? This is strong electrolyte. Suppose lambda m naught of acetic acid CH3COOH equals to lambda m naught of CH3CO minus plus lambda m naught of H plus. Clear now? So that's why this is called a Kohlrausch law. So you are thinking, sir, it is very easy because this data will be given, so we can easily calculate. No. When strong electrolyte value will be given, this data will be given. But for weak electrolyte of, you see, suppose acetic acid is a weak electrolyte. So for weak electrolyte, lambda m naught value will be not given. So how can you calculate the weak electrolyte lambda m naught value from the strong electrolyte? So that's why after this it is coming applications of Kohlrausch law. So the Kohlrausch law has 4 applications. Kohlrausch law has 4 applications. First application is calculations of molar conductivity of weak electrolyte. Second one is calculations of degree of dissociation. Third is calculation of Ka, and fourth is calculation of solubility product. So first here you see calculation of solubility product. Solubility product S equals to kappa into 1000 divided by lambda m naught. These are actually formula based. Okay, so this is called your solubility. Then next is calculation of degree of dissociation. Degree of dissociation symbol is what? Alpha. So degree of dissociation, alpha equals to formula, alpha equals to lambda m by lambda m naught. Molar conductivity divided by limiting molar conductivity is called your dissociation, degree of dissociation. Okay. Similarly, how can you calculate the dissociation constant of weak electrolyte acid? Ka. So Ka equals to formula we know, C alpha square divided by 1 minus alpha. So put this alpha value here. So what will get? So Ka equals to C into lambda m by lambda m naught square divided by 1 minus lambda m by lambda m naught. Okay, so Fourth application was solubility product, solubility. Third is calculation of Ka or dissociation constant. Second is calculation of alpha or degree of dissociation. Clear? Come to the first part. Actually, from this part a numerical will come. So the first part is calculations of molar conductivity of weak electrolyte. This is our target. So how can we calculate the degree of molar conductivity of weak electrolyte? So the weak electrolyte data will be not given. This weak electrolyte molar conductivity we can calculate from the strong electrolyte which data are given. So you see, so the first application, how can you calculate? You see, so our target is lambda m naught of acetic acid equals to this. So now we can convert into like this. So lambda m naught of CH3COH equals to lambda m naught of CH3CO minus. Suppose if you will add Na plus and you will subtract Na plus. Okay, lambda m naught of Na plus. Clear? Similarly, plus lambda m naught of H plus, add lambda naught of Cl minus, minus lambda naught of Cl minus. This data actually depending on the question. So you see, this thing we can write. This is called limiting molar conductivity of CH3CONa, okay, plus this is limiting molar conductivity of HCl minus this is limiting molar conductivity of NaCl. So you see, sodium acetate strong electrolyte, HCl strong electrolyte, NaCl strong electrolyte. So that's why when this data will be given, then we can calculate the limiting molar conductivity of weak electrolyte. Clear now? So that's why. So what is Kohlrausch law? Again, so Kohlrausch law states that the limiting molar conductivity of any electrolyte equals to conductivity of cation plus conductivity of anion. So when, depending on the question, when this data will be given, okay, so after seeing this data, okay, we can substitute in this format. Clear now? So this data given, so you will add these two and you will subtract lambda m naught of NaCl, then we can calculate this. Clear now? Okay, so this is called here Kohlrausch law and applications of Kohlrausch law. Okay, now we will solve some numerical based on Kohlrausch law. Okay, numerical based on Kohlrausch law. So numerical. So first question here I have written lambda m naught of sodium hydroxide given, lambda m naught of NaCl given, lambda m naught of BaCl2 given. Question is lambda m naught of BaOH equals to how much? Clear? So using these three strong data, how can you calculate the lambda m naught of barium hydroxide? Clear? Now you see, how can you solve now? So we know lambda m naught of BaOH whole 2 equals to lambda m naught of Ba2 plus lambda m naught of OH minus. How many OH? 2 OH minus. So how can you calculate this data using this? Now see, so Ba here given BaCl2. That means we'll add, you see, we'll add, so lambda m naught of Ba2 plus was there, so we'll add lambda m naught of Cl minus. So if you'll add one Cl minus, you also subtract one Cl minus. Clear? But you see, BaCl2, for BaCl2 how many chlorine? 2 chlorine. So that's why we'll add 2 chlorine, we'll subtract 2 chlorine. Remember, this is the important. Similarly, next is plus 2 lambda naught of OH minus was there. So OH, here OH, how many OH? 2 OH. So NaOH given means definitely we have to add 2 lambda naught of Na plus. So we have to subtract 2 lambda naught of Na plus. Got the idea? Why 2 you got? Because 2OH minus. So if you add 2 Na plus, then we will get 2 NaOH. Okay, so you see, so after this is lambda naught of, so this is lambda naught of BaCl2 that I given, plus this is lambda naught of sodium hydroxide. How many sodium hydroxide? 2, minus this is now 2 molecules of lambda naught of whose NaCl. So BaCl2 given, NaOH given, NaCl given, put all the values and you will get the answer. Clear? So like this your questions are coming. These are 2 mark questions. Similarly another question you see, lambda m naught of BaOH whole 2 given, BaCl2 given, NH4Cl given. How can we calculate lambda m naught of NH4OH? So lambda m naught of NH4 equals to, we can write lambda m naught of NH4 plus lambda m naught of OH minus. Now using this data, now we'll adjust this. Okay, rearrange. So NH4 plus NH4Cl given. So what we'll do? So we'll add 1 Cl minus. So if we'll add 1 Cl minus, definitely we'll subtract 1 Cl minus. Clear? Next is lambda naught of OH minus, here given barium hydroxide. So definitely you see Ba you have to add. So lambda naught of Ba2 plus minus lambda naught of Ba2 plus, like this. Okay. So if you write in this format, so here something wrong you see. Okay. Because maximum student will write in this format. So after writing you see, this is lambda naught of dash, now lambda naught of NH4Cl. Then this is lambda naught of dash, barium hydroxide. No, for barium hydroxide 2 OH required. But here 1 OH. Similarly, this is barium chloride, but for barium chloride 2 chlorine required. But here 1 chlorine. That's why you will see first. So for barium hydroxide we need 2 OH minus. So if it is 2 OH minus, so from the beginning here it is given 1 OH minus. So definitely you have to write 2 OH. So if it is 2, then it is for how many molecules? For 2 molecules. Clear? So if it is 2, then it is 2 NH4 plus. So if it is 2 NH4 plus, definitely we have to add 2 Cl minus. Yes or no? Then it will come 2 molecules of NH4Cl. Okay. Then this is, so plus lambda naught of BaOH will do. Now see, if you are adding 2 Cl, you have to subtract 2 Cl. Now answer came. So this is whose lambda? So this is lambda naught of BaCl2. Okay. So all the data given. So whatever answer will come, this is for how many moles? 2 moles. So for 1 mole, whatever answer will come by 2. Okay, clear? So these are called actually your Kohlrausch law. So remember, after splitting the main equation, then one cation and one anion will come. Then in cation and anion we have to add and we have to subtract. So when we are adding and subtracting, yes or no, from the given data we have to check whether it is 2 molecule or 1 molecule we have to add. This thing we have to remember. Clear now? So this is called your Kohlrausch law. So like these questions are coming, and also other questions are, suppose lambda m given and lambda m not given, calculate alpha. So direct alpha equals to lambda m by lambda m not. Find Ka. So K equals to C alpha square by 1 minus alpha. Alpha we know, C is the concentration, molarity will be given. So that's why these are very, very important for our exam as well as also for the entrance exam. So clear? So when these questions are coming in entrance, this data will be given in XYZ format. Okay. So quickly you have to calculate within 30 seconds what is the relation. Yes or no? Similarly also here data will be given in XYZ format. Quickly you have to check what are the relation. of here NH for OH and here barium hydroxide. Clear now? So this part is very important. So this part you will try. Okay.